Hello class, we're up to weekly update 3. Several things I've been forgetting to mention. I've looked at your discussions every week, but been forgetting to mention those. So we'll talk about those. We'll talk about your activities and your calculations this week, but a few just general announcements. Late assignments are welcome anytime. So the key thing is that you're doing these materials to prepare you for the final exam. And again, things happen. This is a crazy time in general. So don't just skip it and say, I didn't have time this week. We'd love for you to submit it a week later, 2 weeks later, what it takes. But make sure you email Chloe when you do that and let her know, like, because she'll have a 0, she can replace that. You won't get full credit, but you'll get some credit, and that's better than none. We hate to have 0s in the grade book. Another thing, just continuing to encourage you to discuss and collaborate with your teammates and just other classmates. It doesn't have to be someone on your team. Texting someone, giving them a call, just saying, hey, I just finished this activity. This is what I got was the point. And so early birds, I've noticed people that are submitting, Erin's always on the ball. Like as soon as it opens, she's ready to go. So if you're someone that started at the beginning of the week and looking to say who else is doing this, Erin's a great one. Phoebe does stuff early. James, Jake, Gavin, Haley, Calvin. Those are generally people that are done at least a day or two before the deadline. So if you're that case, like there's some people to reach out to if you want to discuss the concepts or check your work. So Chloe sent an email about the challenge problems and grade summary. So expect something from her in the next few days. And as usual, though, the onus is on you to demonstrate to us that you understand either the point of the activity, how to do the calculations, or for the challenge problems, you need to show us your group participation, right? That's on you to demonstrate to us your role in your participation. If we made a mistake and it didn't look like someone who's not in the class named John, but so if there was a John in the class and it didn't look like John did that much for this activity or this challenge problem, we're gonna give you a lower grade, but we're happy if you can demonstrate to us that that was an inaccurate assessment that Chloe and I made. We're happy to revise that. Okay, general announcements. And now on to the specific activities and homework that we're due this week. So first thing, again, I forgot about several discussions, so I'm gonna run through some of those real quick. First one was on tech tools, favorite tech tools. Overwhelming by far, it's the TI calculator whenever you have to do calculations. Interesting to note that Erin wasn't allowed to use calculators in high school, so she didn't have much attachment. It's usually the TI-84 that seemed to be one of the most common. And then for other tools like Desmos, GeoGebra, Mathway, when you're doing calculations, it seemed that the TI calculators were great. If you were into visualization or graphing, people seem to like prefer Desmos to the TI calculators. And when you're finishing this class, we're doing, we should do this chapter, partial derivatives. We'll do higher dimensional functions. It can even, doesn't do a great job graphing in R3, but again, we've got a great tool, CalcPlot3D. But the TI-89, if you haven't heard of that, or the TI-Nspire, those are ones that can do symbolic manipulations. Okay, then the next discussion board was math is. There's some really interesting answers here, so I'll just mention several themes that I saw. So the idea that math is satisfying, it's systematic, it's a puzzle. Many people mention this. Tripp, Cole, Isabella, Haley. Haley had the idea of a maze versus a puzzle, which was an interesting one. She thought it was more of a maze. Let's see. Oh, this was an interesting one. Formulas as a story. James liked to think about that. He talked about the wonder, the curiosity, and the frustration. And he used the word detective. He likes to think of solving these problems as you're like a detective. Many people talked about the beauty, again, the puzzle, but the therapeutic aspect of doing math. That was Grant. It reminded me, actually, some of Grant's comments that reminded me of a quote by Newton. It's something to the effect that I can understand the motions of heavenly bodies, but not the madness of people. So I think that was what drew Grant to math, the beauty of math. People talked about the math as kind of like a blueprint, its utility. That was Noah and Connor. Several people talked about the pride in figuring something out. I liked Calvin's discussion in particular. Universal language, math is a universal language, was Gavin, Madeline, and Wade. Dave is the only one that really spent some time talking about proofs and axioms, so he really likes the theoretical foundations of math. folks that appreciated the difficulty of it and got some sense of accomplishment. That was Kendra, Maximus, and Aaron. It was the path. Chris's comment reminded me of the show Billions. It's the path to billions that underlies many of the financial world. Oh, and then Phoebe talked about the objectivity. To her, she liked the sort of objectivity that things seem right or wrong. And what's interesting, the higher you go up, the less you find some of that objectivity. There is more gray area. And then Kyla had a nice discussion about the creativity of it and that there was more than one approach. There's often many solutions, and she appreciated that about it. So thank you for those. Those are really, really interesting to read. Okay, then a derivative is, that was the discussion. For some reason, the dates were messed up on the discussion. So I think you're going to have this next week where you're going to talk about, I asked you what a derivative meant to you. What do you remember? And then next week, you'll talk about a famous mathematician who won the Fields Medal, William Thurston, came up with at least seven different meanings of the derivative. And so many of you touched on one of those, which was the rate of change. Gavin and Sharika mentioned the velocity and acceleration. Going a little bit further, Maximus and Grace talked about a derivative was just a simpler derived equation. And then Madeline talked about the derivative as a mathematical operator, which is, we will see that as one of, I think, one of the seven that Thurston talks about. Okay, on to your activities, and we'll share the screen here. So let me pause to pull this up. Okay, so here we are in your Oaks, the usual place. So we're in module 2, samples and examples, week 1. So I put in a bunch here, so we'll see, just point out some names. Lauren, Kendra, Calvin, Jake, Noah, Isabella, Haley, Phoebe, Tripp, Calvin, Noah, Madeline. Those are some folks that I put in. In particular, I want to look at a few. Calvin's activity. Yeah, this one's activity, yeah. So his activity here, I liked his, again, he wrote down some of these because he said he's still getting used to it. And many of these, you're right, like some of them you can do in your head. What's the derivative of 2xy with respect to y? With respect to x is 2y. So no problem, didn't need much explanation, but some other ones he had to sort of write out and show the steps. And that's absolutely how it's going to be in the beginning, and even in the end for ones that are harder, right? So this was a little bit harder functions. And so I really liked also on this one, his discussion of the gradient compass and how he put this over, this was a small little fan, he put a shirt over there and shows the compass at different places. And it's showing how that gradient compass is 2D, even though you're on a 3D surface, you're at a point and you're pulling this thing out of your pocket. And that's actually what is being plotted when you do a gradient, because a gradient lives in a 2D in the XY plane. Okay, and let's go back to samples and examples. Another one, Jake's. I really like Jake's here for the activities, and the reason being, Jake showed to do these partial derivative snakes. Again, you can't do them in your head, most folks. So what he had, this is not Jake's actually, where did it go? It's taking a while to load. Okay, here's our snakes. So he shows the arrows, but here's really how he got to those, right? I mean, he's showing, he even did a triple one here, right? F sub x with respect to 0, and you can continue just as you could in R2. So he's showing all of these, how he came up with that picture there. And this is helpful, right? Because this edition, I decided to put answers for everything. So you can't just show me that, right? You got to show me, how did you get there? Show some work for it. Again, you got to convince us that you know what you're doing. And so he did this, slow down, there we go. For the next one, he shows all partials. So if you want to check, this is a great way to go back through it. All right, and then the next one I want to show is Noah's. So let's go back to week 1. Yeah, so nice images and pictures of points he was at, and then this is the direction of steepest descent. I think he was doing a negative gradient on these. But what I liked was he took that from the R3 surface to showing it on the contour map, right? And in this case, it was a nice little bowl. And so it was always going to be pointing down towards the min, in this case, for at every point. And notice how it's perpendicular to the level curves. Okay, that's great. And then Isabella or Haley were nice ones to look at for the Fisk gradient. So let's look at Isabella's here. So not everyone did this particular one with the Fisk gradient. So there's our snakes. Okay, yeah, so here's the points. And she took the gradients to steepest ascent, really easy to see on the R3 surface, right? But this is the part that some people just have trouble with, is drawing that back down here. She drew the positive in the solid lines and the negative in the dashed lines. And it's not quite always 180 degrees off from each other. They should be pointing in, because it's maybe harder to tell on the surface, but they should be all like this, pointing in opposite directions, the positive gradient and then the negative gradient completely opposite. And answered all the questions associated with this and sort of shows her thought process. Haley was another good one to look at, and that's also in there. Okay, and just in the issue of time, we'll go back, not look at all of them. We'll go to the calculations. So some people that did really nice work, Haley, Phoebe, and Tripp, they did all 4 problems for those pages when you only had to choose 2 out of the 4. They did all of them. Calvin also did all 4 problems, had excellent explanations. Noah, really nice job on the steepest path calculation. So if you had trouble with that steepest path problem, take a look at Noah's. But the one I'm going to show, again, in the issue of time, is Madeline's. Okay, this is just excellent, excellent work. Yeah, here's her partials. She did all 4, showing each piece, and she did this tree to sort of show f sub x, xx, xy, checking that they match. A couple people did that too. That's a nice check. Does f sub xy equal f sub yx? But then here's again, she's checking it. Use your tech tools. Like, you did all that by hand, but maybe you weren't confident because you hadn't done LNs in a while. A lot of people skip those because they hadn't done LNs, but it's a better idea just to take the time to do the ones you're not good at, right? That's how you learn. All of this is meant to prepare you for that final exam. So use this as an opportunity rather than just checking off the list and turning in work, but to say, here's my opportunity to learn something that I'm having a deficit in, right? I'm deficient in this. So she's checking all her work here using a tech tool. Let's see. Same thing, did all 4 here. Describes what she took the first partials and then she evaluates them at the point. That's the only way to do it, but she's showing step by step. But then she also puts these in CalPlot 3D, right? Then shows that, does this make sense? Like, I did this calculation by hand, I got this, but what does that even mean? So she's plotting the vector on the surface with the contour map and in R3 and checking that it moves in the right direction. And then here's the steepest path one again. This is the one probably people had more trouble with. Yeah, going out and around, but that's the correct way. She just says I'm doing perpendicular each time. But there's a few more, oops, I moved down. She has a few more pages of explanation where she actually went ahead and did the calculation, right? A great way to check what you're doing here, and I think that was suggested maybe at the bottom of that page, is you could go ahead and compute those partials, and maybe I even gave you part of them. So she does that, she evaluates them. We get these weird decimals, but that's real life, right? That we're not gonna have nice things like 1 and 2. And then she checks those on the, right? She put them actually on there and says, do they make sense? And yeah, steepest descent is in the exact opposite direction. So excellent conclusion, always with the images and pictures. Excellent work, Madeline. And another thing, if you do have trouble, just for anybody, this took me like over a year to learn, and I think one of you students a year ago showed me this. If you're having trouble getting this in the right orientation and you're like grabbing it and turning it and you don't have as much control over the mouse, use the arrow keys on your keyboard and that'll help you maybe get it to the usual view with Z up and X and Y, if that's what you like. Okay. All right, I think that's it. Again, this was a really fun week because you got to do derivatives in higher dimension, but now we're going to do in the second part even more applications, things you can do with derivatives. So you're going to take other types of derivatives called a directional derivative. So it's going to be another fun week of application. Okay, until then, enjoy.